Good morning. We'll go ahead and get started. Good morning, everyone, and welcome to the March California, Nevada Drought Early Warning System Drought and Climate Outlook Webinar. Thank you to those that have joined us previously and those who may be joining us for the first time. My name is Amanda Sheffield, and I am the Regional Drought Information Coordinator for NIDIS in California and Nevada. This webinar is co-hosted with the California Nevada Adaptation Program, a NOAA CAP RESA team. We host this bi-monthly webinar series designed to provide the region with timely information on current drought status and associated impacts, as well as the preview of developing climatic events. Before we get started, please note that this webinar is being recorded, and the recording and a brief summary will be available on drought.gov and our YouTube channel later this week. We have a great set of speakers this week covering current conditions and outlooks and an update on rangeland conditions. And right before we get started with that, let me give you a quick introduction on NIDIS. For those of you not familiar with NIDIS and our program, our mission is to improve the nation's capacity to proactively manage drought-related risks by providing those affected with the best available information and resources to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. We fulfill this mandate by building a national drought early warning system, or DEWS, through advancing regional drought early warning systems, where we work with new and existing networks of federal, tribal, state, local, and academic partners to make climate and drought science accessible and usable for decision making. We do activities such as these webinars and under 5 bins of categories, including observation and monitoring, interdisciplinary research and applications, communication and outreach, prediction and forecasting, and planning and preparedness. Basically, DEWS collects and integrates information on the key indicators of drought in order to make it usable, reliable, and timely drought forecasts and assessments of drought. With that, I usually use a little bit of time to make brief announcements. This time, I just wanted to talk about something that came out earlier this year, but in case you hadn't heard, NIDIS does have a Helping with Drought funding program, and we recently did have a funding call and awards for ecological drought and tribal drought resilience. And I just wanted to mention 3 projects in particular. You can find these on drought.gov under the link under the story, or go to the Research and Learn link on drought.gov. About 3 different projects that we have going on in California, including a project on the impacts of drought on coastal restoration, improving the tribal sociological resilience to drought, and building regional understanding of the vulnerabilities and effects of ecological drought for conservation and natural resource management in Southern California. So just quickly highlighting those 3 projects here, but you can find more information on drought.gov, and I'll also pop this information into the chat while we get started. With that, as I said, we got 3 great speakers today. I'm going to introduce them here, but if you have any questions for the speakers as we go along, please put them in the questions box in the GoToWebinar panel. Our first speaker is going to be from Benjamin Hatchett from the Western Regional Climate Center at the Desert Research Institute. He's providing the drought and climate update, followed by Nathan Patrick from the National Weather Service California Nevada River Forecast Center providing the outlook, followed by the California Rangeland update from Leslie Roque from UC Davis, and then a Nevada Rangeland update from Patty at the Bureau of Land Management. With that, I'll pass it then over to you, Ben.
Awesome. Thank you, Amanda, and thanks everyone for joining. It's nice to actually have some good news to share about drought for the most part. So my name is Professor Benjamin Hatchett at the Desert Research Institute, and I will walk you through a little bit of what's been an exciting and very largely beneficial year, with some exceptions for those flood impacted communities and heavy snow load impacted communities notwithstanding, but overall, things are looking very good, and so that's really nice to share after many of these kinds of updates where we tend to look at things going the other direction. So we'll start off here with a little satellite loop, a view from space from some of the NASA missions, highlighting our pretty active continuation of winter. So we started off winter with an excellent start with a very active November and December, continued into January, and with a few exceptions in February, the parade of storms continues to make landfall along the western United States, contributing to ongoing rain, snow, and various benefits for drought and impacts to communities from saturated conditions. So the bottom line, drought conditions have been improving and they continue to improve. Just since the last Drought Monitor was updated, there's been even more area that is no longer in drought. You can see on the left-hand side, a substantial proportion of California has no drought. Parts of Nevada, basically the westernmost central Nevada, is out of drought, but we still do have dry to moderate drought conditions throughout much of Nevada and in the kind of interior southern desert region of California and in the northern Sacramento Valley up into the southern Cascade region. So we still have some drought conditions remaining, but largely conditions have vastly improved, particularly in the central part of California and along the coastal regions of California, as you can see along that right-hand side change map over the past 8 weeks. So roughly since the last update, we've seen continued improvement throughout much of the coastal regions and central regions of California, Sierra Nevada, and parts of Nevada, notably kind of southern central Nevada, so areas like Nye County, for example. So conditions are improving. That's very good. And we think that drought conditions will remain pretty good because we have an extraordinary snowpack. This is a lovely image taken yesterday from that same satellite mission, the VEERS satellite, flying over a clear sky, a rare clear sky day. We haven't seen a whole lot of those this year. And that allowed us to see the notable snowpack throughout much of the region. Nevada still has some clouds, so it's a little bit harder to see unless you know exactly where you're looking, but throughout much of the best water tower of California, the Sierra Nevada, you can see very extensive snow cover. And this is just snow cover, not snow depth or snow water equivalent. Both of those are kind of pushing records, if not into record realms. We can also see, it's nice to see a lot of snow in the southern Cascades and Klamath Mountains down into the northern parts of the Coast Range as well. That's nice to see. And then you can also see notable snow in the transverse and peninsular ranges of Southern California as well. So not areas that rely as heavily on snow as many of those that use water from the Sierra Nevada on both sides of the range in California and in Nevada, but it is very nice to see snow so widespread throughout both states. Also the Spring Mountains in the Clark County region just west of Las Vegas are doing very, very well as well. So if you're in that neck of the woods, good time to go see some snow there. Depending how you count it, we're looking pretty close at a top 3, some places number 1, some places maybe number 5, but a very, very, very good, close to record in our roughly, depending how and where again, 50 to 100 year records for snowpack. It's pretty impressive. We're seeing a lot of snow water equivalent records, snowfall records, and this upcoming April 1 survey is going to be really exciting to see what kinds of numbers come in from there. Using our SNOTEL network as a way to get an idea of where we stand throughout much of the West, we are in, like I was saying, top 4, top 1, depending how you count it, what you look at, that can vary. But as far as the SNOTEL records go, we're in excellent shape. And I want to also highlight that not just California and Nevada are in excellent shape, but so too are mountains further inland, notably the Wasatch and Uinta ranges of Utah. That's really good news there. And in particular, note the western slope of the Colorado Rockies, which drains into the upper Colorado River, which many people in California and Nevada rely upon its water. That's also looking very good. So that's good news for a very strained and stressed system, but we probably need 5, 6, or maybe 10 more years of this to really make a big dent in the situation there. But this is much more encouraging to see than dots of other colors. I like blue dots, and this is a great blue dot year. Using California Department of Water Resources view on snowpack conditions throughout the state, really all are in great shape. And you can see here, the northern region is doing fantastic, but it's not quite exceeding that record 1982-83 year, whereas the central and southern regions are close to exceeding that. In the central region, that's probably just above it for that 82-83 year, but in the south, the graph had to be extended in the vertical or y-axis direction because we're heading off the charts, and so this is really impressive and very, very encouraging. But I want to also note that we can't forget some of the negative impacts of snow so far this year, which has caused numerous issues for transportation throughout mountains with road closures, either due to storms or avalanches, such as the case of 395. There's been other road closures in Nevada resulting from heavy precipitation and snowfall and snow melt. We've also seen a lot of structure damage in mountain communities, people being cut off. Those are all issues that come with these big years. And now we're heading into another issue of increasing solar radiation and chances of warm nights and lack of refreeze. That brings up snowmelt flooding concerns. And so that's going to be something to think about as we move into the spring and summer with this colossal snowpack sitting above us. So where did all that snow come from? Well, again, we get to see something a little bit different that's characteristic of these very, very wet years, and that is a persistent ridge of high pressure, not over the western coast of North America, but further upstream, closer to the dateline, and I guess what we would call probably in the central Northeast Pacific, a little bit to the west of the true Gulf of Alaska. When we have a amplified and persistent ridge of high pressure in that position and location on the planet, that helps develop a downstream trough of persistent low pressure that brings cold air, favorable dynamics, and when we have moisture, all of that combines to lead to heavy precipitation, and when it's cold, that precipitation comes as snow, and we like that because snow acts as our natural reservoir. It gives us all of this beneficial use water for later into the season. And so looking at our November through February precipitation percentiles on the right-hand side, we can see that much of California and Nevada have seen above normal to much above normal, and even some locations with record wet conditions. When this gets updated through March, we'll probably see those record wettest areas expanding. But it's also important to point out that the furthest regions of Northern California and Southern California, so places like Del Norte County, Siskiyou County, Imperial County, parts of Riverside and San Bernardino County, were actually below to somewhat even much below normal in terms of precipitation. There's also a few locations in southern Nevada as well, in parts of Nye County and Clark County, that did not see near normal precipitation. So it's not ubiquitous, but vast areas saw lots of precipitation and snow. We also saw cold conditions. Of course, can't argue with the freezing point. Humidity will help a little bit, but we need cold conditions to favor snow, and we've seen a lot of snow in a lot of places. There's been snow to very low elevations along coastal regions of California. You probably heard about it in the news. Throughout this year, it has been colder than normal. This is another graph that we don't tend to see as often in climatology these days, are the green colors, the below normal colors. And so throughout the water year, we've seen very cold conditions overall, particularly focused in the northern Sierra Nevada and parts of Northern California, as well as northeastern Nevada as well. But by and large, very cold. And just the last month, if it's felt extra cold, well, it has. It's been even colder. Note a different different color axis where we actually are upwards pushing into the places have been in the -10 or even colder in terms of degrees Fahrenheit throughout much of Northern California and the Sierra Nevada, and very widespread throughout Nevada as a whole as well. So cold conditions overall this winter, cold start to the spring, nice things to see. And this well above normal precipitation really occurred along coastal areas of California and in the central Sierra Nevada and southern Sierra Nevada. So you can see in agreement with those earlier figures shown with regards to snowpack, really we're seeing the best impacts of beneficial precipitation in the central and southern Sierra Nevada and along much of the coastal regions as well, where we are way above % of normal. Those precipitation departures are on the order of 8 to 20 inches of liquid. And in some places, we're starting to see areas that are pushing into the 60, 70, or even more inches of total precipitation this year. And that's a result of this winter storm trajectories that commonly brought storms to make landfall in that Central Coast region. So there's been a lot of storm-related impacts in Central California, Monterey counties, Santa Cruz County, San Luis, Santa Barbara counties in particular as a result of that. And then again, noting that the furthest north regions and furthest south regions haven't gotten as much liquid this year. Regional hydrology flows are way up. We see lots of blue dots, green to blue dots, and even black dots, indicating that flows are well above to way above normal. Spillways are flowing, water is flowing throughout the regions, with a few exceptions in places that have not started to melt yet. That's something to think about in terms of the Lake Tahoe Basin in particular, as well as parts of northwestern Nevada. All that water has not started flowing. It still is being held as snowpack, but flows vastly are up everywhere. And that's indicative of soil moisture conditions that are upwards of the 95th percentile, meaning that only about 5% of the time there's more soil moisture. This is a fairly coarse resolution perspective on that. So we know that there's very, very high soil moisture in very localized areas, but broadly we see green colors throughout much of the West. This is good to great for snowmelt runoff season that's upcoming and has numerous benefits for our ecosystems. We like soil moisture because that brings us vernal pools and ephemeral streams. Those are just real nice to walk by or ride your bike by and enjoy, and the critters really like them. Lots of good things going on with this wet year so far. Reservoir situation is looking really good throughout California. We're right about where we want to be, I think, in most cases. Can't fill everything up quite yet because we're still just at the tail end of that flood pool season. And of course, we always have to consider how reservoirs are operated to know why we are at average for the year or totally full, like in the case of Cachuma, and there is some flood impacts going on in that region of the San Ynez River. But things are looking pretty good for the most part, with the exception of the Lake Powell situation. Hopefully that will fill up a bit more this year with that good snowpack and favorable soil moisture. But that's kind of the one looming concern over all of this is the state of the Colorado and the water situation there. Something of interest, active weather means very cloudy conditions. We've seen much below normal shortwave radiation throughout the year. And as a result of that, because it's been stormy and cloudy and precipitating and cool, we're not seeing as rapid of a green up as one might expect for such a wet year. So this will probably rapidly accelerate with time, but if we look at our normalized difference vegetation index for the past month compared to the past 20 odd years, you can see that the southern Central Valley, the San Joaquin Valley of California, parts of the coastal regions are starting to green up, but largely there's a lot of brown on that map, and that's because things are just rolling a little bit slow. It's been cool and it's been cloudy, and a lot of areas are covered in snow along parts of the western side of the Sierra Nevada and southern parts of the Cascades and northern coast ranges. And so a quick fire thought, or maybe you could call it a hot take on this, is so we have a lot of benefits coming from these drought relieving storms, but I think it's important to not get totally caught up in all these benefits, because we want to consider what all of this water is going to do to our fuel loading. And this image I shot yesterday, I think really highlights how fuel loading across size classes, especially the fines, which are going to be very good for carrying fire, and the overall fuel connectivity and arrangement, both in the horizontal and the vertical, are going to impact our upcoming fire seasons in the subsequent years. And so as things start to cure and dry out, and we're thinking about curing in terms of dead and down fuels, but then also live fuel moistures as things get warmer, what's going to happen with that? So this is a good year to really think about what's growing, how can you deal with it to reduce your fire risk in upcoming seasons. So to wrap up with some considerations and conclusions, it's been cooler than normal and wetter than normal this cool season, so October through present. We have an exceptional snowpack that was built and continues to be maintained throughout this year. Soil moisture is great and greatly improving or improved over many locations, and we've had large areas of drought amelioration, if not termination, occurring throughout California and Nevada. Reservoirs are in a good shape. We got to keep our eyes out on the horizon for sunny heat waves that are going to lead to snowmelt concerns. When we get the spring freshet, that can lead to lots of new flood problems, clear sky flooding, one could call it. And then I think a final point is to highlight this fact that drought is always looming, especially in a hotter and thirstier world. And so I pulled a couple Drought Monitor images from the year following a big winter. So we had 2011, 2017, 2019. Those were all really great years that did a lot of improvement on the drought. But 1 year later, look where we might be. And so I want everyone to just kind of think about what can we learn and what can we do about when we get these occasional wet years to improve our drought and climate resiliency overall. So we're in real good shape, but we should be thinking about the future always. Thank you very much.
Thanks, Ben. One quick question why I'm changing speakers. You probably answer this because I think others do this. Do you run analysis of what the reservoirs will look like after the snow runoff?
So it's an excellent question. I personally do not do that, but many of the state, federal, and local water agencies do perform those calculations to estimate what the reservoir is going to look like based on, they can parse out all the allocations and who gets water throughout the year to figure out where those reservoirs are going to be. And so that those answers can be provided by different entities that are responsible for managing the different reservoirs, because all the reservoirs have different operations and ways that they're run. But excellent question.
Thanks, Ben. And I realize including perhaps our next speaker here from the California Nevada River Forecast Center. You want to go ahead and take it, Nate?
Sure. Are you able to hear me?
Yep.
All right. Thanks for your presentation, Ben. I am one of the hydrologic forecasters at the River Forecast Center. And so I just have a shameless plug here for photos like this. This really helps us with our day-to-day operations and particularly in locations where we don't have a lot of data. So thank you, Bruce Thompson at the BLM and Tim sharing this information with us. I'm not certain of the exact location of where this photo was taken last week, but it's near the junction of the South Fork Humboldt River with the Humboldt near Elko, Nevada. And what is striking visually compared to the 3 previous years is the amount of low elevation snow and surface water, making it difficult to even find the stream channel, which actually is here in the lower left-hand corner. Going forward, you can see this same sort of widespread lower elevation snow cover, which has not been observed this extensively in the 3 previous years. I'm going to briefly present the official CPC climate outlook, but then focus on the broad water supply outlook from the River Forecast Center's perspective. What are the positives and also what are the potential negatives during the upcoming melt season and then beyond into late summer? To start off, with the March issuance, La Niña has ended and neutral conditions are favored through early summer. Early spring forecasts suggest a building of El Nino conditions for the fall, but spring forecasts tend to be less accurate. The March 9th issuance also indicated the current tropical Pacific atmosphere is consistent with cool La Niña-like state, despite ocean temperatures relaxing from La Niña conditions. And sort of like what Ben alluded to with high pressure kind of drifting a little bit westward into the Pacific, some will say that this year's La Niña and winter outlooks were a bust. However, the forecast did verify pretty well across the United States as a whole, just not so well for our region. And if you are interested in a brief discussion on that topic, the web URL here at the bottom of the slide provides a good summary of that. The April to June outlook suggests normal temperatures across much of the region with a slight chance of below normal temperatures for portions of northern Nevada. More saturated colors don't indicate varying levels of magnitude, so darker blues don't indicate much colder. And temperatures will play a key part during the spring melt, and how quickly things warm up will play a significant role in helping manage the melting snowpack. Like temperature, near normal precipitation is expected for this time period for much of the region, with drier conditions slightly favored for Southern California. It's important to keep in mind that Climatologically speaking, things get drier from now through summer, so a drier dry can be a relatively small difference. In general, based on the unexpected wet winter, drought reduction is expected to continue through June, but there are some exceptions near the Oregon border and portions of the California deserts. It's important to keep in mind that drought can be measured in a variety of ways, the most common being precipitation and soil moisture, which drought.gov and the CPC outlooks focus on. Not really being accounted for is aquifer drawdown without recharge, and in the case of Southern California, Las Vegas, and portions of Arizona, the reliance on the Colorado River supply, which will continue to be problematic. In order for the River Forecast Center to produce stream flow forecasts and water supply projections, we need to use a variety of inputs. One of those is precipitation. On the left is the quality control grid that we produce internally each day, summed up from the start of the water year and compared to normal through Friday. This would be the precipitation input we use to keep track of our soil states and the building of our snowpack volume in our models. On the right is a similar depiction, but shows the mean aerial average for the Huck 8 basin units, which then would get broken down further into the basins that we explicitly model. As the images indicate, Central California, large portions of the Sierra, and coastal portions of Southern California are extremely above normal to date for the water year. Turning our attention to SWE, on the left is a depiction of what the current snow water equivalent looks like across our area according to NORISC, which uses the SNODAS model. Here at the River Forecast Center, we don't use the NORISC data directly, but it is one source we use to modify and adjust the modeled snowpack in the Snow 17 model that we use. On the right are some percentages of normal. As you can see, large portions of the Southern Sierra are 300% of normal. Elsewhere, 150 to 200% of normal is common. And Ben showed a similar graphic to this, but I think I will go through this because we do include the 2017 year, which is probably the nearest analog to what we're sort of seeing somewhat this year. So people probably have that year in the back of their minds. And so here's another view of the SWE using the California DWR station index products for the Sierra. Different traces correspond to the different years, of course, and I've included two large snowpack years. So the 1983 is kind of what is thought of as one of the highest snowpack years, and then 2017 being the green traces. The current water year are the dark blue traces, and then you can sort of see what is a normal year there shaded in the cyan colors. So the bottom image shows the statewide total percent of April 1st at 225%. But really what stands out is the Central Sierra is above the 1983 trace and the Southern Sierra being well above the 1983 trace. This suggests the melt season has the potential to be problematic for water managers, particularly in the San Joaquin River system where reservoirs are smaller and channel capacity does not match the Sacramento River system. In addition to providing river forecasts at official forecast locations, the CNRC provides probabilistic forecasts at many more locations. Products include water supply forecasts that can help inform out to 365 days based on near-term weather forecasts as well as climatology. I don't have time to show individual locations, but wanted to show how this material can be accessed. So if you are interested in a specific location for a variety of our products, if you go to our homepage here, you can click on the rivers and reservoirs and click this ensemble product points here, and it'll bring up all these dots, and then you can click on it and get more specific information that you might be interested in. I will cover two of the three blue dots that we have here, which are water supply indices. One aggregates, this top dot aggregates sort of the Sacramento River drainage system, and then the bottom dot, blue dot here, kind of aggregates the San Joaquin drainage system. This trend image shows the ensemble-based CNRC full natural season flow or unimpaired flow forecast for April through July on the Sacramento River system, which includes the Shasta, Feather, Yuba, and American catchments. This forecast incorporates current conditions, current weather forecasts, and then climatology as forcing inputs. It does not incorporate hydrologic uncertainty, and so the probabilistic bands being displayed here in color only account for meteorological uncertainty. As of Friday, our median forecast indicated by the darkish blue trace indicates 9.3 million acre feet, which is 190% of the 1980 to 2021 median, but this year does not approach the 1983 record high. Different color banding indicates probabilities of exceeding a certain flow. So the 90% band shown by the lower gray dot right here indicates probabilities of exceeding that at 8.5 million acre feet. And then the 10% band indicated by the upper gray dot is approximately 12.7 million acre feet. This bar chart provides the seasonal April flow through July flow for various years for the Sacramento River Supply Index. As you can see, boom and bust years and interannual variability can be expected. And one thing I wanted to kind of go over is if you were to add up this water year's forecasted flow, which is sort of out here in these traces, if you add them to the previous 3-year observed flow, the aggregated 4-year flow is still below the 4-year mean at 71%. So yes, having an above normal year helps, but the Northern California region is still running a deficit when compared unimpaired stream flow volume across multiple years. Here is a similar seasonal trend forecast for the San Joaquin system. The CNRC forecast is 9 million acre feet, or 304% of the 1980 to 2021 median. Our Friday forecast indicates the San Joaquin system this year may surpass the 1983 seasonal runoff from April through July. And as I mentioned earlier, managing this water is going to be extremely challenging throughout the San Joaquin system. Sudden extreme warm-ups will certainly stress the system, and the system certainly could use a break from additional spring precipitation. Here's the depiction of the San Joaquin seasonal AJ comparison across different years. This year's median forecast is just above the 1983 water year. And like I did at the Sacramento, if you add up the San Joaquin water supply index for this year's water year's forecasted flow with the previous 3 years, the aggregated flow is 96% of the 4-year mean. So a potential record year in terms of stream flow, yet this would only accumulate to approximately what we would expect over 4 years. This is a bit better than Northern California, but of course comes with elevated water management challenges, and individual extreme years that are getting wetter and drier will continue to add stress to the overall system. Depicted here is the similar median runoff forecast for both the water year on the left and the April through July seasonal runoff on the right for additional locations. 200 to 400% is common for Central California southward, and 100 to 200% normal is forecasted across Northern California and the Humboldt Range in Nevada. Forecasted peak flow forecasts are shown in this image. Most of these dates are 4 to 6 weeks later than the last few years, and stream flow will be cold well into the summer months, so please keep this in mind for spring and summer recreation activities. Higher flow and cold water temperatures will be more dangerous this year than they have been in the last few years. As a result of saturated soils, snowpack, and low elevation snow, there is potential for spring flooding in our area, particularly in the San Joaquin, Southern Sierra, and perhaps portions of the East Carson area in around the Reno region, and unfortunately, flooding is already occurring in portions of Southern California, including Tulare County. Many reservoirs across the state are above historical averages. Across the Southern Sierra, particularly in small reservoirs not shown here, there is enough snow to fill reservoirs several times. And once again, it will be a challenge to manage the water without flooding occurring due to limited channel capacity. And so dry and cool weather will be very beneficial this spring to help spread out this risk and make things a little bit more manageable. Here is Friday's San Joaquin River forecast at Vernal, and this sort of depicts what I just mentioned in the last slide. It will likely remain above flood throughout the spring as a result of elevated releases from reservoirs, and the elevated flood risk at this location should be expected through early summer. A drawback to controlling naturally occurring flooding through levees, dams, and other infrastructure is the potential reduction in groundwater recharge. So if feasible, some flooding of specific areas could be beneficial in helping to slightly boost groundwater levels. But of course, this needs to be balanced with protecting life and property. The other thing we have to consider in general with the wet years, the potential for an enhanced fire season. Elevated soil moisture and snowpack should help delay the onset of fire season, but the additional water will help produce additional fuel with increased vegetation growth for fires later in this year as well as upcoming years. And with that, I thank you, and I will turn it back over.
Great, thanks, Nate. With that, we'll move on to our next speaker, Leslie from UC Cooperative Extension and Rangelands. Let me find you.
Okay, hello. Can you see that okay? Let's see. There we go. How's that?
Great, you're good to go.
Great. Okay. All right, thank you. So I'm Leslie Roach. I am associated with Cooperative Extension out of UC Davis, and I'm going to give a little bit of a drought and climate outlook from the lens of California rangelands. So I'm going to give a little bit of the broader California context. Rangelands are incredibly biologically diverse across our state. They span a diversity of environments and range types and climate zones as well, ranging from desert to semi-arid to Mediterranean areas. There's about 57 million acres of rangeland in California, so a little over half of the state, and about 34 million acres of that is grazed by livestock. So in California, this diversity of ecological site types supports what we call transhuman ranching, where livestock are moved between pasture-based forage resources in a seasonal cycle, typically, from the lowlands, the valleys, the foothills in the winter, these annual grasslands, to higher elevation mountain meadows and perennial grasslands in the summer. And a majority of the base ranches in California are in these valley and foothill areas. And they are, mostly privately owned. This is a major forage base for the state, produces about 70% of the state's forage for livestock, which supports a $3 billion annual cattle and sheep industry. And so these annual rangelands are a key linchpin in California's yearly grazing calendar, and therefore provide a critical economic foundation. There are also these annual rangelands, which include both grasslands and oak woodland habitats. They cover about 15 million acres of the state, and they host a diversity of vertebrate and invertebrate plant species. So they hold great social, ecological, and economic value. California's annual rangelands can be particularly challenging in terms of annual rangeland forage production. Productivity is extremely variable, in part because the plant community phenology is so dynamically linked to seasonal weather patterns. A key challenge is that optimum temperature and moisture conditions for plant growth are often out of sync with each other in this system, and I'll touch on that a little bit more in a minute. If all goes well in a typical or a normal year, which never happens, the annual rangeland growing season starts with those fall rains, so that October, November, December timing, fall rain start and growth is initialized. During the winter months, so we get into December and February, plant growth typically slows due to lower air temperatures and lower solar radiation. And then as we get into that later winter, early spring, where we are now, so anywhere from February to April, we should expect that rapid growth to begin as air temperatures increase and solar radiation intensifies. So this is kind of where we should be right now. We see that rapid growth. And then it starts to peak out in mid to late spring, so anywhere from April to June, depending where you are in the state. And after that rapid growth stage, plant production cables out, and you see that once that root zone moisture is depleted. So this is all in a typical year. But as you probably know, California rangelands are extremely highly spaced, have a lot of variability both in space and time, and forage productivity, due to both that characteristic climatic and biophysical diversity of the landscape, and then also how, that the dynamically linked phenology of the annual system. Forage production can vary by as much as 4 times, even more, both, interannually at a given location, and then within a given year at different locations. And this is a 4-panel we like to show. This is of 2 long-term monitoring sites that are being shepherded by Royce Larson, who is a cooperative extension agent down in San Luis Obispo County. And you can just see the differences here. So there's a single site here on the top two panels. It's a coastal site in San Luis Obispo County, and then the bottom two panels are an inland site in that same county. You can just see the difference in, between a wet year versus a dry year. So a lot of variability here, and that variability is only further increasing as climate changes, and we're seeing increasingly large year-to-year fluctuations and instability of the forage supply. And, drought is nothing new to ranchers. Communities reliant on rangelands are potentially the most vulnerable to climate variability, given their dependence on such a highly climate-sensitive resource. This is largely rain-fed agriculture in these annual rangelands. Coping with and adapting to drought, therefore, is, critical to the sustainability of these operations. This was, particularly exemplified during California's, statewide drought just a few years ago from 2012 to 2016. And so, like I said, drought has had a shaping force on the landscape, really for millennia. It's really a rule rather than the exception. This year, of course, is the exception. So where are we? Kind of looking at a drought update. We've seen a few of these maps already. Obviously, we're in a lot better condition this year than we were last year. 1 year ago, I think we were on our second, maybe even third year in some areas of worsening conditions. And so this year it has been really, really favorable, much more positive story. And so I'm going just to give you a sort of a ground view of what we're hearing from folks, from managers on rangelands across California. I'm going to kind of give a little bit of a tour across the state of several regions and what we're seeing. So in northern, northeastern California, obviously it's still a little early in the season. As we just saw, much greater than normal amounts of snow. Late December and mid-March rains have contributed to saturated soil profiles in the valleys. The reservoirs begin filling, with some exceptions like Eagle Lake, which is really the result of some long-term trends that were exacerbated by 2021 conditions. But a little early for Northern California right now to be thinking about what forage production might look like. If we travel to the Sierra foothills, soil moisture is at field capacity generally. We see seasonal creeks are running, stock ponds are full. Of course, as we just heard, continued cold weather has persisted and has potentially been limiting grass growth, as well as that reduced solar radiation. In fact, one of the local UC research stations, which has a long-term forage monitoring site, on March 1 measured, I think, just over 600 pounds per acre of forage production. That is lower than the long-term average, which is about 750 pounds. And surprisingly, last year at the same time, the station reported about 1,400 pounds of forage production at this same time. And that was when we were in a severe drought. So it really just points to that disconnect between optimal precipitation and temperature conditions can have a real impact on forage growth. So we're a little bit behind this year at this time, but with potentially warmer temperatures coming in the next few weeks, it should immensely help the situation. Now coming to the Sacramento Valley, where I am, again, more reports of low forage productivity and connected to declined cattle conditions. And of course, because of those cold temperatures, that might be limiting growth and that reduced solar radiation. But as I said, warmer temperatures are coming and that should help quite a bit. Again, soil moisture is at field capacity. Surface waters have recovered, but some folks are looking at groundwater levels that are still need some boost. And then travel further south in the San Joaquin Valley. We're getting a little bit more variability in reports. So we have several long-term monitoring sites in the San Joaquin area, and we're hearing that forage production is quite variable at this point, ranging from slightly below to similar to greater forage production compared to prior years at those same sites. Again, pointing to colder temperatures, reduced solar radiation might be limiting growth in some areas, but warmer temps coming should help that. Also, lots of reports of seasonal creeks flowing. We also just heard about some flooding as well And then kind of our last stop here is the Central Coast. As we just saw, you know, they have benefited from a lot of precipitation, 150 to more than 200% of normal. So soil moisture is at field capacity and then some. There are some saturated conditions. This is a site that our local cooperative extension advisor has been working on. It's a restoration experiment several years ago. And so, so some flooding, also seeing cold temperatures limiting grass growth, but they expect forage production again to hit that rapid growth period any time now as temperatures warm in the next few weeks. So I just want to recognize all the folks that contributed those photos and information reports from the field from across UC Cooperative Extension. And then just want to, you know, again, reiterate some of the points that we've already made here today, thinking about, you know, drought and long-term impacts on planning. I totally agree, drought is always looming, and this is not the time to forget about drought. We still need to be thinking about recovery efforts and proactive planning for potentially another year of dry conditions. And of course, you know, we see these great forage years with drought always looming that can potentially lead to big fire years. So also thinking about managing those fine fuels across this landscape. And that's all I have for today. Thanks, all.
Great, thanks, Leslie. With that, I'll pass it over to Patty from Nevada.
Okay, can you see my screen?
Yes.
Okay, it's not wanting, there we go. Okay, how's that look?
That's great, you're good to go.
Okay, good. Well, Ben and Nathan and even Leslie provided some of my talk, but I will go through this and we'll talk about Nevada now. Nevada is the driest state in the nation. It occurs in the Great Basin. It's also considered the cold desert. So Nevada's the 7th largest state, and it's also the driest state. So we get about an average of 10 inches of precip, which means that farmers and ranchers trying to grow crops or pasture land are dependent on either a high groundwater or stream flow. So the mountains having a lot of water in them is really crucial for our farmers and ranchers here. And of course, we have extremes in elevation as well as temperatures. And so you can see that our average elevation is actually 5,500 feet, but it has a big range. Most of our valleys in Nevada are around between 4,000 and 6,000 feet elevation. We have over 300 mountain ranges, so those mountain ranges really moderate the different types of precip events that occur across the state. So it may rain in one valley and be dry as a bone in another. So it's pretty interesting to manage operations when you have such variability. So our highest precip is Mount Rose, which sits kind of to the southwest of Reno in the Sierra Nevadas, and Southern Nevada has about 3 inches of precip. Las Vegas is around 4 inches of precip annually. So what influences Nevada's climate? Well, it's basically these geographical factors of where it is in the continent, and the latitude, and the elevations. Most of our precip occurs during the summer, fall, and winter. Fall, winter, and spring. And we sit on the lee side of the Sierra Nevada, so it provides a huge barrier to moisture and the maritime winds. Interesting to try to predict our weather when you sit next to this big range. We had snow yesterday, up to 8 and 9 inches in places in western Nevada, which was not predicted. So you never know what you're going to get from day to day. The Rocky Mountains block the moisture from the Gulf of Mexico as well. We do get some of the monsoonal moisture. It's called the North American monsoon, coming up from the Gulf of California from July to September, and those usually are really strong convection storms, can cause a lot of flash flooding in those areas, but does promote growth of warm season grasses. So we have 4 well-defined seasons, and the terrain responds quickly to changes in solar heating. So our south slopes are beginning to start showing some green up. Leslie talked about the annual rangelands. So I actually was in Bakersfield and saw very lush green growth down there. And as I went up 395, which since has closed, it was very dry. This is outside of Bishop on the east side of the Sierra Nevadas. The meadows are very dry. There was a little bit of forb growth starting, but most of the shrubs were not even coming out of dormancy yet. So difference in annual rangelands and perennial rangelands. As you can see here, the precip that occurs, most of the precip from January to March is through the green colors, 30 to 50% of our precip. You can see from Austin is in the central part of the state, very low precip July, August, and September, as well as Elko sitting up in the northeast part of the state. We get most of our precip, which prompts that growth of our cool season plants. And then if you look at the summer precip, you can see Nevada, it's very little, less than 15% of summer precip in that June, July, August period. But Caliente, Nevada, sitting over in the southeast part of the state, is influenced by the North American monsoon. We had a very active monsoon season last July, August, and September. Caliente received over 5.5 inches of precip during those 3 months. And normally they only get about 8.7 inches for the year. So we saw unbelievable growth of our warm season grasses there. So as we talk about growth factors, precip and temperature are the most important. So right now, Nevada overall, based on our SNOTEL and our climate stations and our scan sites, we are over 100% of precip. However, our temperatures, March is typically when we start seeing green up, have been very, very cold. So very slow. I actually prefer looking at the Palmer Drought Severity Index. It looks at soil moisture as well as temperature. And this is just a comparison of where we were last February and where we are this year. So you can see last year, gosh, 2/3 of the state was very, very dry. This year, it's just the opposite. We have some dry areas in southern Nevada. We're not going to see a big super bloom down there. I don't think. There are flowers starting to bloom, but not that super bloom we were hoping for. And so we've had a lot of atmospheric rivers coming through that have been rain on snow events. So I just looked at snow depth here in these images, and March 9th is the one on the left. And you can see we're pretty snow covered here in northern and central Nevada, but after a storm, there's a couple of storms. This was on the 23rd. A lot of the snow has disappeared with those rain and snow events. So here's a quick look at the winter for some of our locations in Nevada. So Elko is about 5,000 foot elevation, a little over. It's the 7th wettest year. Lots of snow this year. It's the snowiest winter ever. Ely, Nevada, sitting at 6,400 feet, had over 73 inches of snow. And at one time they had 3 feet of snow just in town. Very cold and very wet. Eureka, Nevada, same thing. We're at 6,485 feet there. The wettest time period between December and February. Tonopah is in Nye County. Nye County is showing it to be a little dry, but again, they've had over their normal precip. And Winnemucca, Nevada, which is at about 4,300 feet, again, they're about 150% of normal for that time period. So Bruce Thompson, some of his photos were in, I think it was Pat Nathan's talk. He's been doing aerial censuses. He's a wild horse and burro specialist in Elko District, and he shared a bunch of photos with me. Here's Antelope Valley in Elko County, very snow covered. This was after one of the rain and snow events. Still quite a bit of snow there. Steptoe Valley to the south of there. You can still see a very dry, or I'm sorry, dry, very brown looking, nothing growing. Here's the Humboldt River. I think you saw this. It's east of Elko, actually, or sorry, west of Elko. And we see the river out of its floodplain. And so it's wonderful to see that. These guys will farm and hay these floodplain areas. This is what provides the winter feed. They will do big round bales out there. They go and mow it and prepare round bales for winter feeding. The Cortez Range, which is in central Nevada, Eureka County, still very snow covered. Okay, so I just took a look at the spring leaf index, and you can see this was just last Thursday I took this. Southern Nevada is still showing, starting to show some green up. That's based on lilacs and honeysuckle. And so I looked at my lilac bushes this morning, and they're just starting to bud out. So we should see some expansion. But again, it was 21 degrees here at my house today. Just a quick look at the Veg Drought Response Index and where we were last March versus this March, much wetter conditions. And again, a lot of the state is still in dormancy. So our plant community growth curves in general, we start out our lower elevations, our salt desert shrub will start growing. I did witness that. There is pretty good growth on some of the shrubs and grasses, but here we are the end of March. So I'd say we're about 3 weeks behind at least. And then as we move up in elevation, the Wyoming big sagebush community, that would be on those lower fans below the mountains. A lot of it's snow covered yet, so it should be starting in March. I don't think so. The mountain big sage, again, moving up on the side slopes of those mountains above 7,000 feet, mostly snow covered at this time. So I think we probably, if we start warming up, we will start seeing some growth in April. And as we go up in elevation, you'll see the aspen peak much later in the summer. And then our main forage grasses, the higher elevations, Columbian needlegrass, Letterman's, Basin wild rye, Idaho fescue, blue bunch, all peak in mid-July. So the first grasses we should see start greening up are Sandberg's bluegrass and Indian rice grass. Squirreltail is a little bit later, but we are seeing green on the south-facing slopes around western Nevada. And then southern Nevada. So our communities down there, the creosote bush, the mixed desert scrub, and the blackbush scrub should all start showing some green up down there. I did see some desert wildflower pictures of southern Nevada, so I do know we're getting some blooming green up, but it's not going to be spectacular. And then here, this is western Nevada. Some of our saltbush scrub community and Indian rice grass are showing some green up. I think we are going to have a big flush of cheatgrass though. Cheatgrass loves that winter, spring moisture. And so I think we're going to have a lot of fine fuels. Here's another picture that Bruce submitted to me. This is Jake's Wash in White Pine County, Nevada, eastern Nevada. I have been told that there was actually some thaw. And so there's an ice layer over the underneath the snow, which is really going to delay our green up. So these below normal temperatures have delayed our green up, although we do have abundant moisture. Our growth yield equations predict that we're going to have average to above average growing season for most of the state. And we're anxiously awaiting spring's arrival. This is Brittlebush and Cilia farinosa. This was actually taken in Death Valley. So I do know there are some things blooming down there. All right, thank you.
Thanks, Patty. With that, thank you to everyone for joining today, and thanks to all our great speakers. We do have a couple minutes. I think some of the questions that were asked sort of got answered along the way, so I think I only have time for one or two here. But I first want to thank you all for joining, and thank you, Patty, Leslie, Nate, and Ben for your great presentations. The question I think we can cover quickly, I think it's sort of alluding to what folks are thinking of, have talked about, obviously with certain types of drought ending here. But for Ben and probably Nate, can you go over some key changes people should watch out for if/when El Nino comes later this year, whether that's another dry spell, a stronger typhoon season, or more atmospheric rivers, etc.? What are the experts closely watching under El Nino?
Expect anything, because the world is a different place than the past 30 years. That's a halfway in jest answer to a good question, but that I think is an honest answer. Is while El Nino, we like to think of it as it stacks the deck for the subsequent winter to be more favorable to precipitation events by shifting the latitude of the subtropical jet stream and changing where convection and thunderstorms happen in the tropical Pacific. But that said, and it also tends to coincide with cooler than normal temperatures in the southern tier or southern third of the region. And so Southern California, Southern Nevada typically see a much stronger signal than Central and Northern California and Nevada, whereas that, what we call the, what's the word for it? The middle point of the seesaw, if you will, takes place. So there's kind of this unknown area in the northern part. And so all that said, I think heading into an El Nino type year, we should plan for canonical or characteristic El Nino impacts, but keeping in mind that as the climate system continues to change, many of these historical relationships don't hold nearly as true as they once may have, if they had. There's plenty of debate about that deep in the climatology literature, but I think largely plan for potential of either outcomes, whether that's a dry spell or continued wet. And I think if you're always looking for the range of outcomes and keeping in mind having a plan for what would you do if that happens, whatever ends up happening, you'll be in a much better state to take place and take action for what ends up occurring. Probably not the best answer to that, so I apologize, but yeah, plan for everything, I think, is my take-home point there.
Thanks, Ben. With that, I think there's a few questions we didn't get to. I'll try to follow up offline with our speakers and pass your questions to them and pass the answers back to you. With that, again, I just want to say thank you all for joining us today. I did pop in the chat a couple times where the recording and a brief summary of this webinar will be on drought.gov and the NICE YouTube channel later this week. And I'll also mention that our next webinar is scheduled for Monday, May 27th, and we will be releasing another California Nevada drought status update in early April after we get the April 1 data. So with that, thanks everyone, and I hope you have a nice day.